Greetings to all. In this video, we will be discussing how to determine the axis in case of ECG. So, in basic theory lecture also, I have already discussed that if you want to find the axis, I most preferably I use two leads that are one is lead 1. Let me draw a straight line. So this is our lead 1, isn't it? And the another lead which I usually take example is of AVF. So this is AVF. So let me write them down. So this is your lead 1, isn't it? This is your lead 1, and here you have your lead AVF. Now we need to look at lead 1. So I will show lead 1. So you see here, this is lead 1, and in lead 1 you see the QRS complex. So in this lead 1 you see the QRS complex. Okay, now when you see here, the positive R wave is extending up to here, whereas negative S wave is extending up to here. And when you take the resultant of R and S, it will have positive deflection, isn't it? Because the majority part is covered in positive deflection. So the vector here represented by QRS depolarization will be positive. So when we plot that, so this is lead 1, isn't it? This is lead 1. So this is lead 1. So in lead 1, when I draw that vector representation in positive direction, it will be like this. The vector representation in lead 1 will be like this, isn't it? So this is the QRS vectorial representation in lead 1. Now we look at AVF. So where we have our AVF, so here you have our AVF, isn't it? This is our AVF. So in AVF you look at the QRS complex. So this is the QRS complex here. You look at it and you see here the positive R deflection extends up to here. So again it is positive, isn't it? So when we draw that vector in this AVF, then while drawing this vector, what you will be finding is, so okay, let's draw this vector by green color. So and when we draw this vector, and one thing you keep in mind is that here in case of lead 1, because R minus S we have done to find the resultant vector, so it has a little bit small magnitude than the R itself in lead AVF. So the vector AVF, in AVF the QRS positive depolarization will be greater in magnitude. So now we have drawn two QRS depolarization vector in lead 1 and AVF. In both lead 1 and AVF they are positive deflection. Now what we do next is that we draw an imaginary perpendicular line in them. So I draw one imaginary perpendicular line from here. I may extend it to any length according to the feasibility, and then I draw another perpendicular line from this vector and I bring it here. So you see here the intersection point here. So this is your intersection point here, isn't it? So this is the intersection point here. Now when we draw, this is the intersection point here. Now when you draw a vector, resultant vector, then you will get like this. So the resultant vector will be like this. So you see, now this resultant vector gives the axis. So you see here it is lying between 0 to 90 degree. So it is in normal axis. So the axis of this ECG lies in normal axis, that is between 0 to 90, and somehow it looks around 45 or exact, we need to calculate, but just simply looking at them you can say that the axis is normal. I hope this clears your doubt. Thank you.